Good morning. Now, in today's session, we will learn about compound pendulum. Okay, in the last class, we have discussed about simple pendulum. Now, here we are going to discuss about compound pendulum. Now, compound pendulum is also called by the name physical pendulum. It is a body of any arbitrary shape, that is, it can have any shape and it is pivoted, that is, it is supported at any point so that when the center of mass is displaced to one side, it starts oscillating in a vertical plane. So, compound pendulum is a physical pendulum and it can have any arbitrary shape and it is supported at any point, and when the center of mass is displaced to one side, then it will start oscillating. That's why it's called a pendulum. It will start oscillating in a vertical plane. But in the case of simple pendulum, the entire mass was concentrated at the center of oscillation, right? But here, the entire mass is distributed throughout its length. Okay. Center of oscillation definition and all we have already discussed, so I am not discussing it. Now, consider the figure drawn here. Here in the figure, G represents center of gravity. Now the pendulum is oscillating about an axis passing through S. S is nothing but center of suspension. This is center of gravity. Okay. Now, what is the definition for center of suspension? It is a point at which axis of rotation meet the vertical plane through the center of gravity of the pendulum. That is the definition for center of suspension. Now the distance between center of suspension and center of gravity is called length of the compound pendulum and is denoted by small letter L. That is distance between center of suspension and center of gravity is called length of compound pendulum. It is denoted by small letter L. It is shown in this figure also. Small letter L. Okay. Now this paragraph is similar to what we have written in simple pendulum. That is, let the pendulum is given a small angular displacement theta. Then the weight of the pendulum is mg and it is acting vertically downward. Then corresponding to that, there will be a reaction force at the point of suspension, and this mass which is acting downwards and the reaction force will constitute a torque, and that torque will try to bring the pendulum back to its equilibrium position. The same paragraph we have written in the case of simple pendulum also, and the expression for torque is given by minus mgl sine theta. The negative sign indicates that torque is opposite to the direction of displacement. Now this slide is also similar to what we have written in the case of simple pendulum, just a few changes. So compare these two and study. Now here let I be the moment of inertia and alpha be the angular acceleration given by d square theta by dt square. Then the restoring torque is again equal to tau equal to I alpha d square theta by dt square. Now just compare equation 22 and 23. LHS is the same torque, so you can equate RHS and we will get the expression like this. Now dividing throughout with I, you will get an expression like d square theta by dt square plus mg sine theta equal to 0. Okay, taking this to the side and then dividing throughout with I, you will get an equation like this. Now for small values of theta, we will assume sine theta to be theta. So this equation will reduce to d square theta by dt square mg so here there is one I here, mg, here there is one L also. So sine theta approximately equal to theta. So it will be d square theta by dt square plus mg theta L by I equal to 0. But just rearranging, we can write it as d square theta by dt square plus mg L by I theta equal to 0. Okay. So what we have done, we have just take this one to this side, then after that divide throughout with I, and then assuming theta to be small, we will write sine theta as theta. Then you will get this equation. Now you just compare this with the equation for a simple harmonic equation, that is d square y by dx square, or plus omega square y equal to 0. So here omega square in place you have mg L by I, right? So your time period t equal to 2 pi by omega. Here your omega is will be equal to root of mg L by I. So on substituting this value of omega here, you will get the value of t as 2 pi root of I by mgl. Okay. So this slide is similar, the steps followed here is similar to that what we have done for simple pendulum. Now this is a new discussion, that is if k is the radius of gyration and I is the moment of inertia, then the relation between moment of inertia I and radius of gyration k is like this. This actually shows moment of inertia about the center of gravity g. So that is written Ig equal to mk square. M is mass of pendulum, k is radius of gyration. Then using parallax theorem, that is the total moment of inertia is a sum of moment of inertia about center of gravity and the moment of inertia about the axis of rotation. So that will be the sum will be 1 is I equal to mk square plus ml square. Now substitute this value of I in equation 25. In this equation substitute the value of I, that is here you just write in place of I you write mk square plus ml square. Okay, see that is written here mk square plus ml square. Then m is common, so you can cut it. Then what is left is t equal to 2 pi root of k square plus l square by gl. Okay, that is your equation 28. Now so here if we know this radius of gyration k of the pendulum, then the period of oscillation can be calculated for different points of pivoting. Okay. Now let us consider simple pendulum with the period of oscillation is the same as compound pendulum. Such a pendulum is called equivalent simple pendulum. So that is a question, what is an equivalent simple pendulum? It is a simple pendulum whose period of oscillation is same as that of compound pendulum. Its length is given by this expression, that is capital L is equal to k square plus L square by L. Now here this k square is greater than 0. So the length of the simple pendulum will be always greater than the length of compound pendulum. So why the length of is equivalent simple pendulum is greater than the length of compound pendulum? Because in the case of an equivalent simple pendulum, the length is given by like this. Here capital L is the length of equivalent simple pendulum and small l is the length of compound pendulum. Since in this expression k square is always greater than 0, the length of the equivalent simple pendulum, that is capital letter L, will be always greater than the length of the compound pendulum, small letter l. Okay. Now let us consider a point O on the line is G. That is in here, in this line is G, we are considering as point O. And that let that distance SO be L plus L dash. Let SO will be L plus L dash, which is nothing but the length of the equivalent simple pendulum. Here O is what we have already discussed, it is called a center of oscillation. Now the distance between center of suspension and center of oscillation, as we already said, it is called length of equivalent simple pendulum. Now you can rewrite the period in terms of L dash as t equal to 2 or square root of t equal to 2 pi root of L plus L dash by G. Okay. So in this paragraph, you need to study only what is equivalent pendulum. This paragraph is enough. And this is another expression for time period in terms of L and L dash. So just keep in mind that expression also. Okay, now we are going to understand or study what happens if the center of suspension and center of oscillation are interchanged. That is, will the time period be equal? Here we have derived the expression for time period about center of suspension. Okay, now we are going to derive, or we are going to see whether the time period will be the same at center of oscillation. That is, whether the time period at center of suspension will be the same as time period at center of oscillation. We are whether they are same or different, we are checking it. So for that, what we do is we invert the compound pendulum. Hope you remember, that is, once you take the time period about the center of suspension, you repeated the same experiment by inverting the pendulum. That is, you took the time period by suspending it from the other side, that is, from the center of oscillation. First you did the experiment, or you found out the time period by suspending it from the center of suspension, and after that, when you are not able to oscillate, what you did, at the lab, you just inverted the pendulum and you again repeated the experiment. That is, you try to calculate the time period from the point of oscillation. Okay, I think you remember that. When we reach at the center of mass, the pendulum was not oscillating, and then you inverted its position. Okay, that what you are actually doing was that first you are measuring the time period from the center of suspension, and then you are measuring the time period from the center of oscillation. Okay. Okay, now we are going to invert the compound pendulum and we are trying to oscillate it about the center of oscillation. In such case, the time period is given by t equal to, instead of t you are putting t dash, equal to 2 pi root of k dash square plus l dash square by gl dash. Okay, that is the expression for time period if we are oscillating the compound pendulum from the center of oscillation. Okay, now in place of this k square, you just substitute the value ll dash. Then this expression will become like this. Then dividing throughout by l, you get the final expression for t as t equal to 2 pi root of l plus l dash by g. This is the expression that you have now got for the time period about the center of oscillation. Now you just compare this time period with the time period that you have obtained for the center of suspension, that is given by equation 29. What was it? Same expression. Okay, equation 29, that is time period about center of oscillation, time period about center of suspension is given by equation 29. That expression is the same as that you have got for the time period about center of oscillation, this one. So this means that time period of compound pendulum about center of suspension and center of oscillation are the same. That means these two centers, that is center of suspension and center of oscillation, are interchangeable. That is, the time period that you get at center of suspension is the same as the time period that you get at the center of oscillation. That means center of suspension and center of oscillation are interchangeable. Okay, so up to this much is your essay question. They will ask you prove that center of suspension and center of oscillation are interchangeable. For that, you will have to start from the beginning itself. That is, from the here itself you have to start. Sometimes they will ask write about compound pendulum like that, but most probably they will combine this part also, that is derive an expression or prove that center of suspension, center of oscillation are interchangeable. So for that also you have to start from the very beginning, from this one up to this will be your essay. Okay, now this is another section. Your essay will be only up to this much. Okay, now here we have already wrote an expression. That what was your expression 28? this one, t equal to 2 pi root of k square plus L square by GL. Okay, t equal to 2 pi root of k square plus L square by GL. On squaring LHS and RHS of this expression, you will get this one, right? Now just rearrange this one in terms of a quadratic function. Then you will get an expression like this. Here, this is a quadratic equation in L. So, you will have two roots, L1 and L2. Now, sum of roots we have studied in lower classes. As per this equation, sum of roots, that is L1 plus L2, is given by this one, and the square of roots will be this one. That is L1 plus L2, sum of roots will be this term, and the square product of roots, that is L1 into L2, will be this term. Here, both these L1 and L2 are positive. Why? Sum and product are positive. So, definitely L1 and L2 will be positive. So, we can conclude that for a given value of time period t, we will have 2 points. One at a distance L1 from center of gravity and the other at a distance L2 from the center of gravity. Okay. So, if L1 is equal to capital L, if L1 is equal to L, then L2 will be equal to L dash and vice versa. Based on that, we can draw two concentric circles, means circles with same center. That is, here we are going to draw two concentric circles with center of gravity G as center and radii as L and L dash. That is, this one. This is one concentric circle with the G as center and radius as L. This is another concentric circle with G as center and radii L dash. So we got 4 points, that is S, O dash, O and S dash. Okay. So this you just keep in mind, no need of writing in the essay part. Okay, this is just for your knowledge. Okay, your essay ends here. Only up to this is your essay. So from the beginning up to this. Okay. These and all are just to make you understand a few concepts. Okay. Now this is another section of compound pendulum. That is how to find the maximum and minimum value of time period. Now equation 28, as we already know, it is t equal to 2 pi root of k square plus L square by GL. We have already written that. Then you are squared it, and then after squaring you just differentiate it. Then you will get an expression like this. After squaring you got like this, right? Now on differentiating, what it will be look like with respect to t? This will be 2t dt by dl. Like that you just differentiate this equation, and that is what they have written here. I am not differentiating, you just do the differentiation part. On differentiating you will get like this. Now from this expression, what does it give? It gives the variation of time period with the length dt by dl. Okay. When t is maximum or minimum, dt by dl will be 0, and that will give, if this is 0, then this expression will be 0. That is, k square by L square will be 0, or k square will be equal to L square, or L is equal to plus or minus k. Here we take only the positive value, that is L is equal to plus k is valid, because negative value is meaningless. Radius of gyration can never be negative. Also here, when L is equal to k, d square t by dl square is positive. That means time period is minimum for this value of L. That is, at L equal to k, time period of compound pendulum is minimum, and that minimum value of time period is given by this expression. That is t equal to 2 pi root of 2k by g. So, compound pendulum, the time period of compound pendulum is minimum when L equal to k, and that minimum value is given by this. Now what happens if we put L equal to 0 in equation 8? Definitely time period will become infinity, and that is the maximum value. That is, time period of compound pendulum is maximum when center of suspension passes through center of gravity. Okay, when L equal to 0 means there is no separation between center of suspension and center of gravity, right? L is actually the distance between center of suspension and center of gravity, right? In the case of compound pendulum, when that L equal to 0, that means center of suspension is passing through the center of gravity. So when center of suspension pass through center of gravity, that is when L equal to 0, time period of compound pendulum is infinity or maximum. Okay, in this condition, your pendulum will be in the neutral equilibrium state. That is, there will not be any restoring force. Okay, so you got the values, right? Time period of compound pendulum is minimum when L is equal to K, and that expression is given by T equal to 2 pi root of 2K by G, equation 34. And time period of compound pendulum is maximum when L equal to 0, that is when center of suspension passes through center of gravity. In such case, pendulum will be in a state of neutral equilibrium with no restoring force. Now, in order to determine acceleration due to gravity using compound pendulum, we make use of two of its convenient forms. One is bar pendulum and the other is Skater's pendulum. We will see about that in the coming sessions. Okay, so hope you understand today's class. So this is a very important essay question. What is your essay question? Explain compound pendulum and prove that center of suspension and center of oscillation are interchangeable. So for that essay you have to start from the very beginning, this one, and your essay ends here. Okay, up to this much slide you have to write for that essay. This is only for your understanding. This will be asked as a separate question, that is, what are the minimum and maximum time period of compound pendulum. Okay, so for today this is enough. Thank you.